All right, my mic seems to be working. I have my setup over here. So in this case, we've got red and blue mode. And then we've got sound sensitive mode. Some more sound I make. That's reactive. So I have a few different modes. Right now, I have everything coded in Arduino, which is C. And I am going to change this so that it's going to be all in CircuitPython. So I have the code behind me, which is completely blank. So all of this works, and I have this for the video, which is probably going to go up on YouTube, to show that, there is a, let's see. So I've got a Neopixel strip. I got two actually that are spinning around the whole thing. I have everything connected into an Adafruit Trinket. And that is going into a button, just a basic little button. And then I have a microphone sensor here. It's actually a trigger sensor, but I'm using the analog to detect the voltage. I have this really cool diffused vase. I need to figure out how to... so the light will actually go in the middle of that and be kind of like a torch in there. All right. So the first thing I need to do is I need to double tap the reset button, which if you double tap the reset button, it will put you into a mode where you can load different things on, and I'm going to bring up the internet, and I'm going to download the latest CircuitPython for the Trinket and load it on. Okay, so download latest CircuitPython 4.1, which is great. Download the UF2. All right, so the first thing we're going to want to do is get the Neopixel libraries working again. And I believe I need neopixel.mpy, which is in the CircuitPython library bundle. So I actually have this all downloaded, but there's wonderful instructions on the Adafruit website on how to do this. So I'm just going to go from my download directory in CircuitPython, and I'm going to drop all this in the lib directory. And then I'm going to want my basic code for that. And let's get, so basic code. So in this case, we'll copy everything, and then whatever we don't need, we will take out. All right, so the first thing is, so I have two strips. I have one on my pixel pin is board.a. So let's just see, A4. All right, so my number of pixels, I know I have 55 on each strip. So everything is over here on the right side of the screen. So really, I just want to test and see if these things work. So I'll save here. Perfect. Okay, so it just needed a restart. So this is the device here, and it just restarted when I pressed it. So that's the device. It's a very tiny one. It's called a Trinket, and it's nice and cheap because it only has a few ports on it, which is great. All right, so now that works, so let's figure out where the other one is. So pixel pin A4, and we'll comment this out. And I think it was A2 is the other one. So if I save, that should automatically reload. All right, so A1 is working, and A1 is chasing. Okay, so we have A1 and A4 are our pins. So strip 1 pin, strip 2 pin. All right, so strip 2 is Neopixel. Let's copy paste because I'm lazy. So Neopixel, and take strip 1 pin, strip 2 pin. And we'll keep the brightness at 0.3. That's pretty, let's see, in the video it's not too bad. Okay. So ultimately there's two languages I can code this in. I can code this in CircuitPython, or I can code this in Arduino, which is C. C is much faster. When I tell you, you're seeing some animations here, the animations are almost 10 times faster in C. The problem is it's a lot uglier code, or at least it's much harder to view. And when you're teaching things, I much prefer to be using something like Arduino, like CircuitPython, because this is much cleaner and easier. I mean, this is a variable. I just create it called strip1pin, and I give it a value, board.a4. I don't have to typecast it. I don't have to talk about what the difference between a 16-bit integer and a 32-bit float and things like that. So yeah, so it's just so much nicer to do these things. All right, so all of this is basically going to go. So I have, all these are functions. So in Python, if you want to define a function, use def, the function name, and then parameters. So I'm going to get rid of all of these except I like color chase. So color chase is a nice one. I don't think I need wheel, because I'm going to kind of clear that out. So color chase. Rainbow cycle is really neat, but not really going to use it. We predefine some colors: red, yellow, green, cyan, blue. So all colors are 255 means max, and everything's red, green, and blue. So red is all red, no green, no blue. And then the way Python works, or at least CircuitPython, is everything happens in this while true. So this is all initialization stuff. This is stuff that runs once, and this is the loop that runs constantly. So the neat thing about embedded electronics is, like, when you think of a website or things like that, that's something you go there, you initiate, and like things, magic happens, all this stuff happens, and then with embedded electronics, you just have this stuff that's just constantly running. That's all it is just constantly in a loop, in a loop, in a loop, in a loop, in a loop. So think about something like a lock. So like, the number pad, the keypad locks. That is literally sitting there over and over and over and over again saying, did the user press something? 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 And then you press a button and it goes, hey, the user pressed something. That's really exciting. Let's do something with that. And then it holds it in memory and does all this stuff. Right now, let's test to see if color chase works. So on load, we're going to do, so the pixels isn't going to work. So let's do, so the problem with color chase right now is color chase is taking a color and a weight. But what we want is actually, so what I'm going to do is strips equals an array of strip 1, strip 2. All right. So strip num. So we have to add a new parameter here, which is going to be strip num. And that's just going to be, so strips and then strip num. And then that. And we're going to take our color. And then strips strip num dot show. So what we did here, what I did here was originally it was just referencing a single strip. So here I have an array, which is two different strips, strip 1 and strip 2. And then what it's doing is just basically picking, so it's indexing, saying, give me strip 1, give me strip 2. And worthwhile noting, strips are starts at 0. Each pixel is a single LED. So saying strip, you select the whole line of pixels. Yes. So this is actually two neopixel strips, or two pixel strips. So I have one here and then one here, and I've intertwined them. So so there's not actually one big strip here, there's two, and that's for additional animation and coolness and fun. And these are WS2812, which means they're individually addressable. So a lot of LED or NeoPixel strips that you'll get for like house lighting, or in your case, Marwin, because I know you work on sets, you probably get 50/50s. Now you can get WS2812s that are 50/50s, and that's a whole other story. But most of them have 3 color settings: red, green, blue. But you can't individually address each LED. All you can do is address the entire strip. So you can very quickly make the whole strip red or blue or green or any mixture in between. But what's neat about these is these are individually addressable, so I can do all the neat animations. All right, so let's check color. So let's just do a big comment out of everything. And let's just do a color chase. Let's see, did I have? Okay, color chase on the first strip. And we're going to chase with red. And our weight, I don't know, let's try 100 and see what 100 is like. And then we'll color chase on 1, blue, and do that 50. Comment everything out. And let's just test. So strips 0, fill. Right now there's not a lot of blue, so let's just fill with blue. And then I believe I need to do a show. So the first thing sets the color, and the last one shows the color. I apologize for semicolons. I'm such a semicolon coder. All right, so I saved that. Okay, great. So we've got blue all around, so that does work. Okay, so that's the problem. So that's our color chase with a weight of 1. It's really slow. Boop, 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 boop. All right, so we were just doing it way too long. All right, so let's see if we can do a 0.1. There we go. All right, so while that's going on, let's actually just talk about this function, because I think it's a neat little function. Okay, so again, we passed in the strip number, the color, and the weight animation. All right, so let's actually just do one thing again. Let's have everything. All right, so the one interesting and weird thing about CircuitPython, or about Python in general, is there's no brackets. So if you've ever seen other code, you tend to see a lot of brackets, opening and closing. This is how you start and end things. Python doesn't do that. It forces you to do really good tabbing, because everything is based off of tabbing. So all of this tabbed content belongs to whatever's tabbed previously. So this function, all of the things that are tabbed here belong here, and then everything just gets tabbed out. So yeah. So let's talk about, so we have a strip number, we have a color, and we have a weight. So our strip number is, which strip we wanted. As you saw, there's the red one, and now we have the blue one going. So we passed in 2 different things. So one of them, we did 0, so strip number 0. We gave it the color red, and the delay is 0.1. And then strip 1, we color blue, and we pass 0.1. So we have our first for loop. So for loops are a loop that runs for a given amount of time. So in this case, for I, so we give it a variable, which we're calling I, in range of numpixels. Now, this is not as humanly readable as I think some other languages are. So, for example, like in PHP, you would do for I equals 0. So you start it. I is less than or equal to num pixels I plus plus. Now, this can be a little bit more confusing, but I actually think this is a little more logical. But we won't get into that. But what basically you're getting here is you're going to loop through for all of our number of pixels. So if we go up, our number of pixels is a variable that means 55. So for every number within 55, then what we're going to do is take our variable strips, and our strips is just strip 1 and strip 2. And it's going to pick which number I told it. So I said, all right, I want strip number 0 or 1. And then it's going to pick a pixel on there, and that pixel is going to be that number. So it's going to run through this 55 times. And what it's going to do, so we're picking the next pixel on that strip. So starting with essentially 0 and working our way to 1 and working our way to 55. And then we set it equal to whatever color we passed, red, blue. Then we sleep. So sleep does what you might think it would do. It sleeps, goes to sleep, does nothing for the wait period. Now, I think this is sleep is in seconds. So when I originally had 1 in there, I was thinking it was kind of like microseconds. Nope, it was seconds. So it was once every second. And then it does strip.show. So when you send data to the light strip, it takes time to process. So I could queue up a whole bunch of different changes and then make those requests. So like, let's say I want to change every pixel to a different color. To do that, I would want to send that information once, because then it will update very quickly. Whereas if I send that one at a time to each pixel, it's going to take 55 times longer. So this sets the color, and this says show. And then once that's done, it's got another time.sleep for 0.5. So this function runs, it changes everything, and then it itself sleeps for 0.5 before moving to the next one. So that's what those two functions are doing. Now, the sad part about these functions, I mean, what's neat is, again, you get them up and running quickly. But these will run until they are done. So you call them, they will run, and then they're done. But you can't do anything in between. So I have two different things on here. I have a button and I have a microphone. And I can't read any input from those. I can't do anything unless I do something in between. So the color chase is a good function to test things. And this shows me that all the pixels work. This shows me that the colors work. But I'm going to have to drastically change everything if I want it to look nice. So now what I want to do is I actually want to comment these out. So there's two different types of comments. You can just put in a hash, which puts some stuff in there. So this comments out a single line, and then three single quotes allows you to comment out a whole block of code. All right, so now I want microphone pin is board.a0, I believe. Hold on, let me check. So now what I'm going to want to do here is I'm going to want to read that pin's value, and then I want to output it so that I can see what sort of values I'm working with, so I know how to program and what to work around. So let's see, do I have analog IO? No. Import analog IO. And let's quickly check the internet, because CircuitPython is not my normal language. Analog IO. So analog IO is an analog input-output. And it allows me to read values from an input. Analog in. All right, so I define it, and then I do dot value. Okay. All right. So instead of doing microphone pin, I'm just going to say microphone is analog in board.a0. And then if I just print microphone.value. All right, so now I should see a whole bunch of spam. Okay, so I see a whole bunch of spam here. And that's not very helpful. I'm not sure A0 is where it's attached to. Let me double check. Well, it says it is, but I'm not sure. All right, so let's work on just some animation. So what I want to do is I want to make a little flame animation. And the way I want that to work is I basically want it to flicker like a candle. And I think the best way to do that is just to make it work. All right. So let's sketch out how this is going to work. So what I want to do is I want to set a pixel, and then I want that to determine, so I want the base to be a certain amount of like heat, and then that heat will then slowly dissipate as it goes up. And so I'm going to need some variables for that. Okay, so let's do this as an array so we can write the function once and just have to iterate through each. So heat current base heat equals array. So we'll start out at a base heat of, I don't know, let's just say 25 maybe. All right, so our base heat is going to be 25 and 25. And so what I want here is each pixel is going to lose some amount of heat, somewhere between 1 and 3, and that's going to change its color. So let's set our colors first. So heat colors is, so now we're going to have to do 25. So let's do 5 rows of 5. Okay, so heat values is going to be, all right, if I greater than 0, because we don't want to do this with I being 0. So heat value I equals heat value I minus 1. So we want to go the previous pixel minus, and let me look up how to do random again. Okay, random numbers. Random dot rand range start stop step. Is I for integer? I stands for nothing in particular. What it does mean, hold on, rand int, that's what I want. So random integer. All right, let me just quickly. So I is a variable name. I can call this whatever I want. So I could call this, pixel number. So I can call it whatever I want. It's pretty much just standard convention that you use whenever you're using something that's throwaway. You use a short name that means nothing. So use XYZ, ABC, IJK, because you're never going to use them again. Whereas when I use values that actually matter, like heat values, then I actually write a name, my strips. I write something that is easy to read. But I is something that you just kind of use over and over again in loops. So that's why you use I. All right, so I need to include import random. So when you're writing code, you have to say what libraries you want to use. So we're about to use the random function, which is part of a library. So I have to include that. So random. So we want to randomly remove somewhere between 0 and 2. So what this should be doing is doing setting things down. And then what we want is also now to check. So if heat values I less than 0, and I just forgot, we need colons, then heat values I equals 0. So we don't want it to go less than 0. And I think we needed to reverse this. So here's the problem. I have my hottest value at 0, because the array starts at 0, and then it goes to my coolest value, which is at 225. So in fact, heat colors is an array of heat starting with the hottest and going towards the coldest, and then black. Okay. In fact, let's add black. All right, so that's fine. What I've added here is I want to make sure that the heat value of my previous number is also greater than 0, because once we're at 0 heat, you're not going to take any more away. All right, so we're going to subtract a random integer, and if it's less than 0, then we're going to go to 0. All right, so now let's print our heat values, and let's just see if they make any sense. And let's add a little bit of a wait in here, otherwise this is just going to go crazy. Let's wait a whole half second. All right, so let's save. All right, so good. We got a bunch of errors to fix. Line 55, code error. Did I put and? I forget. I don't know. I code in so many different languages, I can't remember. 51, we have a problem. What's wrong with 51? Index is out of range. Maybe, just maybe, this is what they want. Oh, Control D. All right, 55 doesn't like that. All right, so let's just do one at a time. If I greater than 0, if heat values I minus 1 greater than 0. Okay. So now, all right. So now the issue is in 56. So it's here. So heat values I minus 0. Okay. So what's happening here. So I is going to be 1. So heat values, okay, because heat values has multiple things. All right. For j in 0, 1, because we have our two strips. That's the problem here. We have a multi-dimensional array. So heat values j. So the problem was we have two different set of heat values because we have two different strips. We have 1 and 0. So I need to do this loop twice. All right, so that should work. Should. Hey, heat value is not defined. Good. That's a solvable problem. Okay, 58, code index out of range. All right, so let me walk through all that again. Because I'm a noob cake. All right, so what I did here, so things were actually working again. So I initialized all my heat values with two different, basically, for loops. So for x in range, numpixel, so basically setting everything as 0. Then I set the first value as 20. We have our heat color array here. Our heat values are actually showing, so we have 20, 19, 18, 16. So you can see it's kind of going down. They're all going down towards something. I'm not sure why there's a 5, 3, 2, 1. We can kind of figure that out a little bit later. but we're getting, the same thing here. We get a jump here. I'll figure all that out. But that's debugging, and we'll get in there. So we're going through all our heat, so we did our random setting of heat values. So now we're assigning those values to the pixels. So I take my, I'm doing this twice for 0 and 1. I'm doing it for each pixel, and I'm setting the strips of whatever my number is, 0 or 1, to whatever pixel number it is, to the heat colors. So I'm looking at the array heat colors, and I'm doing 20 minus my heat value, because we're starting at a value, 0 is our hottest value. So 20 minus heat values, Ji. So J is my strip number, and I is my pixel number. Then I'm showing strip 1, strip 2, and then sleeping. So in this case, we'll sleep for 1 second, and we will wait for all the things to be ooh. And the colors are actually kind of nice. So let me reduce this to 0.1, and actually let me kill some of the brightness. So the brightness was originally set to 0.3, so let's set it to 0.1. Hold on, let me get rid of these print statements. The print statements are actually drastically slowing everything down. Yeah, so when you have to output anything to the console, it makes everything super slow. Yeah. Well, the problem is this is not actually very bright. This is actually pretty not bright. In fact, that's my camera's flashlight. So that should give you an idea. Like, these are not that bright. In fact, if I pump it up, right now it was at 0.1. So if I bump it up to like 0.7, yeah. If I put it at 0.1 and then put it in the diffuser, so that actually looks quite a bit like a flame. So I'm actually really happy with that. It's not perfect. That's actually a lot better now that I turned my other pixels off. So the problem with this, or at least the problem with what we've done, is this. So we are starting with 20. And in theory, we could have a complete flicker where the entire strip gets... so we could have a randomness where nothing ever decreases and the first 20 pixels are all at 20 heat. And we could have something completely opposite where everything's dropping off by 3. So if I want it to be more natural, then what I really want to do is I want to... I probably want to have a natural change. So I would want to go through each pixel and basically determine, do I want to increase or decrease it? And then everything below that will obviously have to decrease, but it won't be complete, like it'll have to be more organic. So let's see, how can I make it more organic? So this function is not working because anything could get anything get killed, could get decreased. So so we could pick a random pixel somewhere in between and say that is where things are going to get less. And then, all right, let's do that. All right. So we know that worked. So let's comment it out. All right, so let's realize. So right now we have all right, so let's start everything as a gradient. So for I in range 0, range, let's see, 20. Heat values 0, I equals I minus 1 minus 1 if I greater than 0. All right, so everything is going to start out very linear. So let's just test this to make sure it works. So for I in range num pixels. So we need to set this. All right. So this should just give us a nice gradient. And then let's leave the sleep in there, just so it's not constantly looping. All right. So now this should give me a single gradient. Okay. So I have my full color gradient. I know the camera doesn't love picking this up, but I've got kind of a blue going to a yellow and then going to red. So I've got gradients, and I've got the gradients on both sides. Okay, so it's at least working. All right, so now what I want to do is I want to change this around a little bit. So I want to change the way we change heat values. So this was good. So we know this works, and we know the sleep works. And what we want to do now is so let's just do this. Def random change. So we now have a function called random change that will just randomly change them the way we did before. But what we want to do here is we want to do a more logical heat change. So what I want to do is I want to start all from the same point, and I want to randomly pull heat from some areas, and I want to randomly add heat from some areas. And that way, it'll cause things to kind of grow and shrink and come in. All right, so let's pick, So we'll always have 20 at the bottom. And then, all right, let's just have some rules. Let's go through each pixel and then have some rules. So instead of being completely random every time, we're actually going to make some intelligent choices on this. So this is all going to be fine. It's what we're going to do after that's going to matter. All right. Okay, so we're going to go through each one of our pixels in each one of our strips. And if it's not the first one, we're going to make some determinations. And if the last one was 0, then we're just going to or if the last one was greater than 0, and else then heat values j I equals 0. Okay. So if we're greater than 0, if our previous one was greater than 0, then we need to figure something out. So let's take a look at what our value is versus what the previous value is. So if heat values j I minus 1 minus all right, so if our previous value minus our current value is less than -5, -4, then heat values j I equals, so let's increase our current value. All right, so basically what's happening here is if our previous pixel is really hot and we're now cold, we're going to heat ourselves up while decreasing the heat of our previous one. So all the heat is going to be maintained. So heat values j I minus 1 equals heat values j I minus 1 minus 1. Okay. So if our heat values are very different, let's borrow. And let's do else if, let's do the exact opposite. So if we have more than 4 heat than our previous, which can never happen. Okay. That should never happen because we should always be less. We should always be less than or equal to. All right. Okay, so what do we want our next if statement? All right, so if we're too low. All right, so if we're the same. So if heat values equals our current value. Okay, so if our values are equal, then let's subtract. Because we don't want to stay that, like, you're going to quickly lose heat. Okay, so I is I minus 1. Okay, fine. Else, if heat values j. All right, so we know in this case, if no. All right, so we know in this case then it's somewhere between 1, 2, and 3 different from its previous. So what we want to do in this case is basically either randomly add or subtract. And what this is going to do is slowly but surely the fire will go out. Oh, this is perfect. Else heat values j I equals heat values j I plus, what's my random dot int was random, no, random dot randint. So -1 and 1. All right. So let's see. Is it going to compile? Of course not. Line 90. What's broken on line 90? Did I do else ifs wrong? Let's check the internet. Again, Python not my language. Python else if. Give me an else if. Elif. Okay. Just good old elifs. Else if. Line 90. Oh. So I have to do a double equals here because it is a comparison, not assignation. Yes, exactly. This spell failed to cast. Oh. It's alive. List out of range, line 101. Okay, so I have a heat value that is below where it should. That makes perfect sense. Yep. Okay. Thank you much. Yep, okay. So yeah, so basically what I'm doing is I'm doing the check at this time. Oop. So now it's slowly fading. Now that looks more like a flame. So now the problem with this, or I shouldn't say the problem, where we can improve is really increasing. So right now our heat colors were 20. If we go back up here. So I'm really only setting the first 20 pixels. So really what I want to do is another thing I just realized is I am potentially subtracting, which means there is a chance that I will be less than the value I have. So do I have that set up? So if my heart value, so my heat value of the previous minus the beginning, or current, or really what I should be doing is current minus previous is less than 4. So the current minus the previous is less than 4. Does that make sense? What am I really trying to say here? If the current minus the previous is greater than 4, that's what I want to do. All right. So if current minus previous, no. All right. Wow, it's late. All right, so if the current value minus the previous no, the bigger one should be the previous. So if the previous value minus the current value is greater than 4, then my current value is going to increase. That is what I want. Okay. So if the previous minus the current is... Yes, so if there is a greater than 4 difference, so it starts out like heat 20 and this is heat 16, then I want to increase my current heat and then possibly decrease my previous heat. Okay, that makes sense. Otherwise, if my previous is equal to my current, then I'm going to subtract 1 from my current. My strips are wrapping around the tubes. You'd need to skip the number in each wrap to make the heat go straight up. Yes, I don't necessarily want the flame to go straight up. I could do that in theory, but what I was hoping to get is I like that wrapping. I mean, it kind of gives a tornado effect. So you most certainly could have some skipping. And then otherwise, we're going to go plus or minus. Okay. Now, all right, so let's see how this works. Well, it's got some flickers. It looks much better not on camera. Let's see, hold on. Yeah, the LEDs just don't do justice in here, but it definitely, especially when I put the diffuser on. That really does give it quite a bit of a flame. I mean, really, what I want is there's a sound sensor on here. There's a button on here, and I want this to be animated and interactive. So I think it'd be really nice to have something that looks like a flame, even though this is a highly digital thing.